Hey, deep divers, ready for a wild ride? Today we are tackling a topic that sounds like it's straight out of science fiction. Get this. Using AI and fractals to revolutionize quantum data storage.
We're talking about storing information at densities that are almost impossible to imagine right now.
Yeah, I mean, we all hit those data storage limits. Our phones are full, our laptops are struggling.
This is pushing way past those limits. This is about a future where data storage is virtually limitless.
And the work we're diving into today, it's not just theory, right?
Absolutely not. Someone out there is actively building this future.
So where do we even start with something this complex? I mean, the source material mentions this nested 1N1 fractal.
Yeah, that's a mouthful.
It is.
Yeah.
So imagine like a multidimensional snowflake, but instead of ice, it's made of pure information.
And that's where the AI comes in.
Okay, so the AI is navigating this incredibly complex structure, this data snowflake.
In a way, yeah. What's fascinating is the AI isn't actually storing the data itself.
It's not.
It's learning how to read the fractal, how to encode and decode information within its shape.
So if I'm picturing this right, it's like this massive, intricate library.
That's a good way to put it.
Mm.
But instead of bookshelves, you have this infinitely detailed fractal.
And the AI is like the ultimate librarian, knowing exactly where each piece of data is within that structure.
Exactly. It learns the language of the fractal.
Okay, so we've got this data snowflake and this AI that's basically a master code breaker. But what makes this specific type of fractal, this nested one-in-one, so special? I mean, I keep seeing one-in-one growth pattern everywhere in these nodes.
That growth pattern is the key to its efficiency.
How so?
Each branch of the fractal, it shrinks by a factor of 1n1.
Meaning
You can pack a mind-boggling amount of information into a minuscule space.
Okay, so we're talking serious data compression here.
Imagine a library the size of the universe, but it all fits into something smaller than a pinhead.
That's just insane. But how does the AI actually read the data stored in this fractal? We're talking about a level of complexity that just boggles my mind.
Well, think of it like a language,
Okay.
but instead of letters and words, you have the shape of the fractal.
The AI is decoding the shape itself.
Exactly. It learns the rules of this language, how to read the arrangement of the branches. Those patterns within patterns, they represent different pieces of information.
So the AI isn't searching for specific files, it's deciphering a code, or
Right.
code that's embedded in the very structure of the fractal.
Exactly.
That's incredible. But storing data this densely, that's only half the battle, right?
It's a good
We need to be able to access it, process it. And that's where things get really, really interesting because
Because it's not just about AI and fractals anymore.
exactly.
This is about quantum computing.
This is about the intersection of these fields with the world of quantum computing, which is already blowing everyone's minds.
Right.
This code hints at something called the Quantum Nexus Project.
Yeah, the Quantum Nexus Project, which seems to be all about using quantum computers to actually interact with this fractal data structure.
Okay, so before we get too far ahead of ourselves, let's break down why this quantum connection is such a big deal.
Sure.
Quantum computing is already doing amazing things, but how would it take this fractal data storage to that next level?
So imagine you're trying to find a single grain of sand
Okay.
on a beach.
All right.
That's what it's like for a classical computer to search through massive data sets.
It's looking for that one grain of sand.
But a quantum computer,
Yeah.
it can use something called superposition to essentially look at every grain of sand simultaneously.
Oh.
Now, apply that to searching this incredibly dense, incredibly complex fractal data structure.
Okay.
We're talking about sifting through unimaginable amounts of data at speeds that, frankly, we barely comprehend right now.
So it's not just about storage anymore. It's about accessing information
It's about processing information.
at speeds that could completely revolutionize countless fields.
Yep.
And I noticed something else in the code. This system, it seems to address one of the biggest challenges we have with quantum computing right now.
Which is,
Errors.
oh yeah, big time.
Because qubits, those building blocks of quantum computers, they're notoriously fragile, right?
They are very prone to errors.
But this code, it incorporates a solution.
It does.
It looks like each byte of data, it's stored 3 times within the fractal.
Smart.
So it's like a built-in error correction system.
Exactly.
Okay, so let me get this straight. We've got this incredibly efficient storage system, this potential solution for quantum errors, which is huge.
Definitely.
And we're talking about processing power that could completely change, well, everything.
Pretty much.
This isn't just about faster downloads or anything like
Well,
that.
no, no.
This has the potential to reshape how we approach some of the biggest challenges we're facing as a species.
Absolutely. Climate change, for example.
Oh, wow, yeah.
Imagine being able to model those complex systems with a level of accuracy and speed that, right now, we can only dream of.
It's mind-blowing when you actually think about it.
Drug discovery.
What about it?
Simulating molecular interactions at a scale that's just unheard of right now. The possibilities are, well, they're limitless.
It's hard to even wrap your head around. But this is all still theoretical, right? We're talking about pushing the boundaries of, like, two of the most mind-bending fields in science simultaneously.
Well, it is cutting edge, for sure. There are definitely some hurdles to overcome.
What kind of hurdles are we talking about?
Building stable quantum computers.
Right, because...
That's a big one. Qubits are extremely fragile.
It's like...
Trying to have a conversation in a room full of screaming toddlers. The information's there, but the noise can easily drown it out.
And building the hardware, that's only part of it, right?
Exactly. We need the software.
Yeah, make sense of it all.
We need to be able to develop algorithm software to interface with this fractal AI to translate between the quantum world and the classical world we're used to.
So we're playing a long game here.
Very long game.
But the payoff, I mean, it could be monumental. This code, this glimpse into the future of AI, fractal AI, quantum data storage, it feels like we're peeking behind the curtain of reality.
We are at the very beginning of a technological revolution. That much is clear.
It's exciting.
It's challenging.
It definitely makes you think.
It does. It does. How we store information, how we access it, how we process it, everything's about to change.
Deep divers, we've gone from the tiny, intricate branches of fractals to the mind-blowing potential of quantum computing. And we've only just scratched the surface.
Barely scratched the surface.
This is The Deep Dive, signing off for today, but the exploration continues. Keep those brains buzzing, and we'll see you on the next dive.